Alright, hello everyone, and welcome back to my flight with the Beechcraft Starship. From Black Square, we are flying out of Anchorage and heading towards Seattle. Whether I actually do the whole flight today, I'm not entirely sure. It depends on the timing. I'm starting a little bit late, so I might end up... Well, Stewart is a little bit short, but maybe we'll go to Juneau or Stewart. We'll see. We do have two launches to cover today. It turns out that there is both an Ariane 6 launch scheduled and a Vulcan launch scheduled. So I've got those windows open and we'll watch them if they happen. But you know how launches are. So anyway, let's get started. Everything is live right now and that should be okay given the timing. We'll just start on the runway and proceed. Oh, I hear a phone call. Let me check on that.
Anchorage Tower, Ray Eyes Romeo Alpha 412, ready for west departure at runway 15.
Ray Eyes Romeo Alpha 412, altimeter tree 009er departure to the west approved. Cleared for takeoff runway 15.
Alright, that was nothing, but I am
Cleared for takeoff
waiting
runway
for
15.
something,
Ray
potentially.
Eyes Romeo Alpha 412.
Anyway, let's get this going. Right. Just making sure that's okay. Alright, 495 miles to Juneau at least. And it's 13 minutes to the live stream for the Ariane 6, so I'm not going to start the Apollo 13 audio right now, since we'll only be able to listen in for 13 minutes. And after that, there is the potential Vulcan launch. If the Vulcan launch doesn't happen, or if it does happen, I mean, we might still pick up the Apollo 13 audio after it. So I'll just say that after the launches happen, if they happen, then we'll listen to Apollo 13 again. I sure have a lot of browser windows up. Hopefully that's not going to be a problem. I'm just configuring the Ariane capture, hopefully. Thought I had one that would do this properly. Let me see. Okay, that looks fine. So we've got that, but I'll hide it for now. And we would like throw in my fuel. Okay, we can go. Out from Anchorage. Come on, little cursor. Okay, we're all configured. And we have 7 minutes to the Ariane 6 stream. Hello, Pekka. So we're waiting for Ariane 6, which the stream seems to start in 7 minutes. I guess I'll keep it in the upper corner. Let me get that. There, we're all prepared, but I'll shrink it for a sec. I need to access some other things. Mountains looking okay. Mesh seems good. Texture is not the best. Well, I flew places with this plane, that's all. Don't know what to say exactly. We were listening to Apollo audio. I've survived. And in this plane I've logged 60 hours. See, it says flight hours there, 60. It's been 60 hours. This is a especially fancy plane because it has all sorts of potential failures that haven't failed, but they have mean time before failures here. I could have them fail now, but all these things can fail randomly, and then you can change the failure rate too. And then it has engine simulations. The only time that the engines seem to get damaged is during startup, actually. So, and it has temperature simulation too. Make sure our pressurization is set right. I haven't seen anything cause a blackout because of pressurization though. Not once in this game has anything caused a blackout. Very fancy, yep. This is a Burt Rutan plane. This plane is so fancy. When you drop the flaps on the rear wing, it does have flaps, even though it's sort of configured like this. The canard has to sweep forward. It's actually a variable geometry canard. So if I deployed the flaps, the canard moves forward. Burt Rutan, yep. Designer of the Rutan Boomerang and Spaceship 1 and tangentially Spaceship 2. Also the Voyager. He really liked these sorts of things, yeah. Pusher props in general. The Rutan Long EZ is also this sort of configuration. I'm waiting to see how loud the Ariane 6 stream is going to be so I can adjust the volume. But unfortunately, this plane was not so successful because it basically costed as much as the business jets. The business jets were appearing, and the business jets went faster than this, so people went with the business jets instead. What Spaceship 3? I don't know which Spaceship 3 you're talking about. Hello, Sheebs. We're waiting for the Ariane 6 stream. Is there a Spaceship 3? I didn't even know there was one. Let me look. Planned class of space planes by Virgin Galactic teased on in 2021. It seems like they were cancelled. Well, they had their countdown going and their countdown completed, so in theory they should have started the stream by now. They are late. Hopefully we won't have too many clouds getting in the way of the landscape view. Community. Well, that's not a billion-dollar company, is it? Well, Marianne's still taking their time, fashionably late. Let me just see. Seems like it's still supposed to be at the same time, which is about 32 minutes. And then the Vulcan launch will be 19 minutes after that in theory. They're developing something? Well, that's nice to hear. Yeah, the Vulcan launch probably won't show us the upper stage or anything. Little plane wobble? Well, it's wobbling. I guess there's some turbulence. The engines are especially happy, as you can see. Yep, that face. Dings? Which dings? There's so many things on. Don't know which ones you're talking about. Yep. A little bit hot there. Never turns on the lights. Well, just low is fine. Oh, among the fancy features, there is a diskette back there. There's a data diskette that you put into that drive at the beginning that contains nav data. Also, somebody said a game, but I haven't seen the game yet. Metal on metal sounding thing. Well, I make some sounds too, like my mug saying on the desk. That happens. Mug hitting other mug. That's that. Something for completing something. Oh, huh. I didn't hear that myself. An achievement unlocked sort of sound? I didn't catch that one. Oh, is this? Oh, they're live. Oh, why is it not capturing them? Okay, there we go. Oh, sometimes my firewall pops up with something for connecting to the internet. But I didn't see one this time. The audio, their audio? Well, their audio is coming direct from the computer.
Hello, and a very big welcome to the European Spaceport in French Guiana and our live broadcast Road to Space. On the pad we have Europe's new heavy lift rocket.
Oh, let me turn it up for them. No, that's as loud as that gets, really.
For its third launch, and on board is our passenger, Metop second generation A1, the first in a new series of European weather satellites, which will also improve our predictions of extreme events like storms and better understand climate change.
I mean, which audio are you
Carries
talking about,
6
Cheebs?
instruments on one satellite, including Sentinel-5, to analyze our atmosphere as part of Europe's Copernicus
You mean
Earth
the
observation program.
SpaceX Starship?
Now, we
They
are
were
about
supposed to test
16
today?
kilometers from that pad,
From
and
this- from their
overlooking
stream,
the
right.
Mission Control Center. Indeed, that's actually our view from the commentary box. I'm Katie Haswell, and joining me is Vincent Baudel, who is our rocket expert from Arianespace. It's great to have you with us, Vincent.
Yes, hello Katie, and hello to everyone. So great and exciting to be here tonight in Jupiter for this new YouTube Live.
Now, Vincent and I are going to be with you right through until separation of our satellite, and that's going to be happening in about
For
an
them,
hour and a
yeah.
half's time.
Well, I don't know. They
We've
might
got
be on
lots For you
location.
between now and then, we'll be discovering our satellite and its 6 missions on board. We'll be finding out about operations across the range.
I mean, if they're at
We'll also
Kourou,
be
that's
meeting the
different.
teams starting here in Mission Control. We call it the Jupiter Control Center. There it is on the right-hand side of the screen. Very much the nerve center of operations. The teams in here inside what we call the fishbowl. It's the glass protecting them and making all the final decisions in there as well.
Yes, and there will be as well the Ariane 6 launch site. That is a dedicated area designed for launcher final.
Oh, you're
separation.
talking about
So it
Pekka.
includes, of course, the launch pad, but also the launcher assembly and the integration building.
We'll also be meeting the teams in the Launch Control Center.
Who's
or
detanking?
CDL, as it's known here.
Oh,
on base.
Starship,
Closer to the
Starship's
pad.
detanking.
These are the teams who are responsible
Gosh, with
for
3
the
different
operations
things
on
going
board
on.
and the pad right up until liftoff. Laser focus concentration in there now.
Yes, and we will discover.
Yeah,
as
it's
well
even
the
worse.
telemetry team, and
It's
so
2,
stimulate
right?
The real-time data with the launcher sensor, which allows us to continuously analyze the launcher behavior and confirm that it is as expected.
Indeed. Now, let's find out how things are looking for the launch, and who better to tell us than the CEO of Arianespace, David Caballoles. David, how are operations progressing?
Well, so tonight we are going to operate Ariane 6, which is a brand new heavy launcher of Europe. So Ariane 6 is now on its launch pad.
Iron
All
6.
the indicators are green, the meteo is okay, and we should be able now to perform the launch in a little bit more than 20 minutes.
Great. That's
Not
good
making
to
fun,
hear.
just
And
musing
tell
that
us a
that
little
might
more
be a
about
better
our
name.
passenger.
For sure. So today our client is EUMETSAT, so the European institution in charge of meteorological satellite, and for EUMETSAT we launched a very special satellite called METOP SGA-1. So this is the first of a new generation of polar orbiting weather satellite, and within this satellite we have 6 instruments, 6 very innovative instruments, and it's worth noting that one of them is called Sentinel-5, and it's part of the well-known Copernicus program of the European Commission.
Indeed, so a very important satellite, not just for Earth observation, not just for our planet, but for literally for each and every one
Very
of us
Western
on Earth.
Europe. Okay.
Yeah, absolutely, because this satellite will provide extremely valuable data
Big.
to increase the accuracy of weather forecasts, but also to allow scientists to better understand climate change, to fight against pollution. So this is really a satellite that will provide a tangible outcome for all the European citizens, and for this reason, at Arianespace, we are extremely proud to proceed to this launch tonight.
Absolutely. Well, David, thank you very much indeed for keeping us up
Britain?
to date there. David Gavayolis, thank you. Right now, just a little reminder, if you happen to be watching us on YouTube, don't forget you can click on the bell to subscribe and follow
Is it?
our launches. I highly recommend
France
it.
isn't in
It's,
Central, so
always
France
nice to
France
see what's
is
going on, and we do have an awful lot
France
going
is
on
in
here
Greenwich,
at
isn't it?
the spaceport.
I mean, it's the same as Britain, isn't it? Or do they have Central Time?
I
thought they were GMT.
We are all green and go for launch. Our satellite's due to lift off in 21 minutes and 33 seconds. What's going to happen after that?
Yes, so tonight the Ariane 6 launch vehicle will lift off toward the north, powered by its
Not
main
only, it's not
solid
just
rocket
one
engine
person
and
in
its
Britain,
two solid,
but yes,
propellant booster.
Safe-ish
So
certainly
this
is.
will be separated 2 minutes and 15 seconds after launch, followed 1 minute and 17 seconds later by the fairing separation once the launcher has left the Earth's atmosphere. The launcher will continue its ascent up to 7 minutes and 35 seconds when the main stage will have finished its job.
Yes.
So the onboard computer
Britain-
will command the shutdown.
Well,
of the weekend
UTC is a little
and
bit
the main stage will
complicated.
be
Britain is
separated.
GMT.
A few seconds later,
UTC
the
sort of,
upper stage engine will be
I forget if they
connected first
do
time and will burn for about
summertime
12 minutes, putting
or
the
not.
launcher into a
Daylight
new
savings
target
time.
orbit. We will then
If they
have a
don't,
long
then
gusting
yeah.
phase going up around the North Pole
but
and
we're
down
not
Eastern
UTC.
Asia
I mean,
until shortly
are you
before
even
the
UTC minus
when
6
the
right
upper
now?
stage will be reignited close to Australia.
I mean, like, the
This
West Coast is
similar boost,
normally
which
UTC
will
minus
last
8, but it's
only,
actually UTC minus 7 right now.
47 seconds will allow to reach the targeted orbit, therefore METOP SGA-1 will be separated. And after that, the upper stage will enter a new costing phase before a third boost, which will slow it down, followed by
The East
steady
Coast would be
acceleration
UTC
and
minus
leading
4.
to a re-entry above the Indian Ocean. And this
Britain is
deorbitation
currently UTC
will
plus
avoid,
1
of course, leaving any debris in
because
orbit.
they do
Any debris,
daylight
this
savings, I
is-
believe.
Very
But
important, of course.
they're
Avoid
still
space
GMT.
debris.
That's
And,
weird.
METOP SG
As far as I know,
released,
that's the
it's gonna
distinction
start
between
the
UTC
process
and
of testing
GMT.
and calibrating before it can start its job. That'll be in about a year's time. And my goodness, what an important job it has. With people across the world coping with increasingly extreme weather events, there's never been a better time to improve the accuracy of our weather forecasts and our climate predictions. And that's exactly what our satellite's going to be doing.
Yes, Europe's weather service EUMETSAT is launching its new series of polar orbiting satellites.
Do
So the
Europeans
second
have,
generation of,
like,
METOPs.
daylight
It
savings
consists of
time or
6
summertime
satellites built by
debates
Airbus
as well,
Defence and Space, working in pairs and with an A-type and a B-type.
where people want to get
And
rid of it?
today we are launching the first one in the second generation, and it is an A-type. That's why it is called METOP SGA-1. That is to say,
You do?
METOP second generation A-type number 1.
And on board, it actually carries 6 instruments.
Well, that's
from
nice.
6
It's something that
different
unites all of
complementary
us.
methods. One of them is Sentinel-5, as David was telling us earlier, which is part of Europe's Copernicus
Turns out
program
it's universal.
to monitor our planet, and it's very much our eye in the sky for air quality. And that's important because air pollution contributes to millions of premature deaths every year worldwide. So this is super important. Sentinel-5 is going to track pollutants, greenhouse gases.
The textures
and
around here are
ozone
really
levels
horrible.
across the entire planet. So let's find out a little bit more now about our satellite, METOP SG-A1.
Well, I think we when I was younger, we used to switch at a different time. I think you guys are switching at the same time that we used to, and then we changed the time that we switch.
On board is METOP SG-1, the latest in Europe's family of polar orbiting meteorological satellites, developed by EUMETSAT.
We actually decided to spend more time in daylight savings time.
Its mission to provide the data we need to understand the weather today and the climate of tomorrow.
I don't know, you'd have to look up why, I don't know the details.
METOP SG-1 scans the atmosphere from pole to
I'm
pole,
doing
collecting
fine, thank you,
high
Jakovsky.
precision measurements,
Welcome.
temperature, humidity, and trace gases.
Temperatures in Europe
Hold on,
are rising
I'm
twice as
checking
fast as
something.
average. This makes Europe the fastest warming continent in the world. Data from the first generation of METOP satellites was a game changer, while data from the second generation, the first of which we'll be launching tonight, will continue that, ensuring that it is the most important source of space-based observations in numerical weather prediction, covering the period
Well,
of
I think I'll just publish that video.
until 2040.
Built by Airbus Defence and Space, METOP SGA-1 carries a new generation of instruments, hyperspectral sensors, and microwave images designed to detect even the smallest changes in the atmosphere. It also hosts the Sentinel-5 mission, part of the European Union's Copernicus program. The Copernicus Sentinel-5A is the evolution of the Copernicus Sentinel-5B.
Well, let's see how this
currently
does.
in orbit. This new satellite will perform atmospheric measurements at a high spatial, spectral, and temporal resolution related to air quality, methane emissions, ozone.
So we're flying over Alaska right now,
New mission, together with the geostationary
while
Sentinel-4
listening to the
and
Ariane
the
6
upcoming
launch,
CO2M mission, secure Copernicus
and
as one
waiting
of the
for the
most
Vulcan
advanced
launch.
Earth observation systems in the world when it comes to atmosphere monitoring.
Oh, it's the lunar mission with Kasei that I did on Saturday and Sunday.
The European Union cements its position as global leader in the provision of Earth
Okay,
observation
let me get the video caught up there.
by orbiting the Earth.
When I go to a different browser, it pauses the video, so
Global data,
the
pollutants,
Ariane
and
stream.
other atmospheric trace gases, which will be used by the Copernicus Atmosphere Monitoring Service for
I don't know, I mean, the
METOP
landing
SG-1's
video didn't do so well,
observations
so
will feed
who
models
knows
for
what people want
numerical
this
weather
time.
prediction, enabling them to
What
become
what
precise,
actually interests people
numerical
anymore? I
weather
don't know.
prediction models
Maybe everybody's
underline
bummed
many
out by
aspects of
space.
modern life.
I blame Elon.
Weather forecasts up to 10 days ahead.
Also blame
climate
KSP too,
research,
but
and
more Elon.
database policies. Working behind the scenes, the satellite helps protect lives and guide governments in the face of what's ahead. In
Oh, you mean
addition,
the Vulcan, yeah.
countries in northern latitudes will also be able to use data from the METOP SG satellites to improve nowcasting that is crucial for disaster management and early warning
SpaceX
for
brain? I don't know.
Extreme weather is one of the main causes of
You mean
destabilization in the world.
pro SpaceX brain or anti SpaceX brain? Because I think they're more anti.
The European Method Program contributes to this forecast.
Well, I mean, by now I've probably filtered out everybody who's only interested in starships, so I don't know.
Second generation one will provide a range of continuous high-resolution observation essential for operational weather prediction. This mission demonstrates Europe excellence in Earth observation. Go, MetaPSG, go.
Together, Ariane 6 and METOP SGA-1 embody Europe's ambition to ensure that space innovation leads to greater resilience on Earth.
And indeed, space technologies do play a huge role in enhancing our everyday here on Earth. But of course, we've got to get them into space, and that's our job today. And to do that, we need a spaceport, and our spaceport here at the European
Eventual
Space Station
Starship
is a great place, isn't it,
series.
Russell?
Yes, the European spaceport is a very big place.
I don't
so
know.
nearly
Well, they seem to like the
700
Junkyard
square meters.
space program game,
So it-
but that I don't think there's been
corresponding
updates
to
to
6
that
times
yet.
of, the surface of inner Paris to give you
So-
an idea.
Yeah, indeed. And we
Maybe
call
if there's
the
a-
whole thing, the range,
If Kitten Space
Yes,
Agency does
station
something,
dotted
maybe, I
along
don't
the
know.
flight path. And because everyone's spread
What's
out
it gonna
across
take?
the range, everyone's got to be looking at the same information, and that's why all eyes are focused at this point before launch on the status panels. You saw them back there in the Mission Control Center. We can see them, but they're throughout the
Junkyard,
spaceport.
yeah.
And right now the panels are all green. That's a good sign.
Yeah.
So tell us about the panels then.
Yeah, so the status panel shows the live go, no-go status across the base. So, as you said, all must be green for launch to go ahead. And they show us the health of 3 main systems across the base. So, of course, the launcher and its ground system. You can see Ensemble de lancement plus lanceur. There is as well the satellite, of course, METOP SG-A1.
Sure hope there's a
a
satellite.
subgroup dedicated to the range, including the telemetry, the radars, the weather, and of course the safety.
And the teams watching over those are in the Launch Control Center. We met them earlier, CDL. As
Then
we
what
call
was
it.
the other one
They
that
deal
was-
with everything to do with the rocket and the launch zone. What are they doing right now?
Another
Yes,
game,
so
wasn't
the,
there? Competing.
The launch control center.
Was it
so the
Space
CDL
Flight
is
Sim
where
2
the
or something?
INS
Or what was it
and
called again?
teams
It was
are
something
getting
2.
The launch pad and the rocket ready for liftoff.
Yeah, Space Flight
So
Sim
these
2.
are the operations team, and they're sending the various commands to turn the launcher avionics on, to fill the propellant tanks. to
Shuttle
pressurize
again?
the
Well,
tanks
I
and to do
I
all the
am
plan
collecting
tests to
those. I haven't
confirm
done
that the launcher is
STS5
ready,
fully
for
yet.
launch.
I was working on
And,
that.
behind them, behind
But I've got the
glass
videos for
windows,
STS1 through
the
4 that I
engineering
had
teams
recorded.
are monitoring all these operations closely, making sure that all parameters are as expected. So they are following all physical parameters, temperature, pressure, electrical current, and so on. And these teams are working in tandem and in real time
Full
with the teams in the
RSS.
Space Code Control Room in Paris.
Well, we'll see how that
Who
looks.
designed and built the rocket, so they are also monitoring the launch from across the ocean, and the teams communicate with each other.
And will they have mod support?
And
I
monitor
assume they have mod
operations
support.
and take important decisions.
Indeed, and that's good. The more people on the job, the better. Right now we had the pre-final weather check, if you like, at T-20. Everything green there. We've got the final. weather
How
check
good will
coming up
that
in 40
be?
seconds at T-10. What kind of things do we have to look out for?
Yes, so first we need to monitor the high altitude winds, so between 10 and 20 kilometers. So we need to make sure the wind speed and direction are below a certain limit, not because the launcher.
Well,
cannot
there's a
withstand
melting
it,
glacier for you.
but for safety reason in case of launcher malfunction. And we need also to monitor the risk of lightning during the ascent to avoid being hit by lightning, which could harm the launcher avionic. We monitor storm clouds, and on the ground there is not such a problem because we have 4 lightning masts, as you can see.
Primarily
on the
for
screen.
mobile,
So
yeah.
4 lightning masts to protect the launcher while sitting on the pad.
And we use a weather balloon, don't we?
Enough?
Yeah, we use
Enough?
weather balloons,
Hmm.
carrying
I don't know,
instruments,
a whole lot of
that
our
send back
Space sim
information
games for
on,
PC also
the
seem to be
temperature,
based on
pressure,
mobile
and,
too.
humidity. And we use
Well,
as
yeah,
well,
I'm gonna be doing
sensors
Mars as
around
well.
The launch base and along the coast for the wind.
We'll be testing
and,
the
for
Mars
the
stuff
lightning.
with Kasei next
And
soon.
the weather status panel is green, so that's good news. We go for launch. We've had some very clear skies in the last few days here, so fingers crossed for a very beautiful launch tonight. 9 minutes and 14 seconds to go. Here on the pad, we've got various things we can look at. You mentioned the lightning towers. Have a look at that great big building behind the rocket. It's called the gantry, and it's got various jobs, but the rocket is actually, it was protecting the rocket before the launch, and it's
Yeah,
actually built on
well,
great
who
big
knows
wheels.
with
It rolls
KSA.
back just before launch. launch.
Yes, so the gantry, the mobile gantry, so it is a very huge structure, so 8,200 tons of...
There's some
metal
room for a
structure,
game
so
that
it's
actually
about the
has
same as
humans,
the
but
Eiffel
quirky
Tower.
humans.
So it's built
Like
on
actual
wings,
human
and,
characters
it
who are
rolls back
interesting, but
just before launch.
nobody's
It travels
gonna
very
try and do
slowly
that for a
along
while,
set of
probably.
frames at 7 meters per minute. So 90 meter high and 40 meter large, and 120 meters rolled back.
Very big. Now, this was some weeks ago, the operations to prepare the...
Yeah, so the cryogenic stages of the launcher arrived in French Guiana on the brand new cargo ship called Canopy, which is also powered by wind. So they were then transferred to the spaceport, and launcher operation started with the horizontal assembly of the main and upper stage in the launcher assembly building, followed by several verification and checks. Mid-July, the
Little
integrated core
astronauts.
stage was transferred to the launch zone on an automated guidance.
Can't see their
vehicle.
faces? Well, then
Once
there's no point.
It arrived on the launch pad, it was
That's-
vertically tilted,
Yeah.
lifted up inside the
I mean,
mobile
I guess
launcher,
it's okay,
and
but
accurately positioned on the launch table.
probably not
And
good
of
enough.
course, two boosters were then transported to the launch pad, and of course integrated onto the main stage. After that, our passenger, Method SGA-1, arrived in French Guiana in mid-June. The spacecraft container was transferred to the preparation facilities, where it was unloaded in the clean room. Some inspection, checks, and health tests were run. Then the spacecraft was transferred to a special hazardous clean room where it was fueled. The combined up started with the mating of the spacecraft on its fly adapter. The
Children?
spacecraft stack was then transferred to the final
Boring
assembly
humans for
building,
them.
where it was integrated on the Ariane 6 launch vehicle adapter.
Well, it's
And
tough
after,
to come up with a
final,
compelling character.
Cleaning and checks, the two half fairings.
That's why I
were
mean, they're not the
positioned
only
around
ones.
the
Like
spacecraft and
Astroneer
fairing
has sort of
assembly.
generic
The
little
satellite and fairing stack
astronaut
was
figures, and a
transferred
whole
to the
bunch of
launch
other
zone by
games
road,
have the same
and
thing.
once arrived on the launch pad, the composite was hoisted inside the mobile gantry and integrated on top of the launcher, an operation completed last Wednesday. And about
Faces are
9 hours
complicated.
ago, the mobile gantry was rolled back.
Indeed, to reveal our rocket. And of course, rolling back the gantry marked the beginning of what we call the actual final countdown. There have been lots of operations, haven't there, in these last 9 hours or so? What are the highlights?
Yes, so after the gantry was removed, all the propellant line were flushed.
And then
to
there's
avoid
that bird
any
one.
leftover humidity in
Which isn't
preparation,
really a space
of
flight
cooling
simulator,
lines,
but
and then the start of fueling, which started around 6 hours before launch. In parallel, there have been electrical checks and harmings, getting the telemetry and radars ready. And now we are in stable situation, waiting for the start of the automatic synchronized sequence.
And that's coming up in the next 20 minutes, seconds. Our range
It's
operations
20 minutes,
manager getting
seconds?
ready
What?
to announce it. He's picked up the phone.
oh, bird one. No, what was it called? Starbirds.
So the synchronized sequence, the automatic sequence, is normally the last 5 minutes of a countdown.
Relaxing
So far,
asteroid
we
base
have not
building and
actually
resource
received yet
management game.
a confirmation that that has been triggered. We're looking at green status panels. And we're hoping to hear soon from the range operations manager.
À tous de DDO, séquence finale lanceur passée à
You're
Agio
gonna
en
hear
5
some
minutes.
interesting sounds. Hold on.
Okay, so we have
Has he announced the beginning of the sequence?
Yeah.
He has indeed. Okay, so that's good news. The last 5 minutes of operations, and lots going on during this time.
Does she
Lots of
speak
very,
French
very
at
detailed
all?
operations and very fast times to the millisecond.
Yes, and all those operations are very precisely timed, combining system checks and pressurization of the cryo tanks, activation of different systems and valves. The control of the operation is gradually being transferred from the ground to the computer on the launcher, and it will be the launcher
Sleep
on the
deprived?
computer
Possibly.
who will actually send the main engine ignition command. The same computer will check the main engine before sending the fueling arm disconnection and booster ignition commands for liftoff. Since we have a fixed launch day today, fixed launch today, sorry, without a launch window.
Early?
if
I
we
think
have
you
a
mean
stop
late,
running
right?
event,
I mean,
we will need to postpone the launch.
presumably they stayed
So
up.
we're looking here at our rocket on
But,
its path.
I
Just a
mean,
couple
I'm
of
still
things
are they
about
in
the
Europe or are they in
initial
crew?
sequence. We're going to switch the Vulcan engine on before we
I'm
switch
not
on
even
the
sure
Yes,
about that.
7 seconds before liftoff, the Vulcan engine is ignited. That allows to
'Cause
check
at
it
Kourou,
is
it's not
running,
that late.
correctly, smoothly, before we ignite the boosters.
And let's just briefly tell people about the cryogenic arms.
French Guiana, well, okay, French Guiana is sorta Europe, but not continentally.
So they're clamping onto the top of the rocket, and they are feeding cryogenic fuel into the top of the rocket very, very ultra.
And definitely not
Yes, so the
like
cryogenic arms are
time
13
zone
meters
wise.
long and 20 tons. Huge mechanical arms connected to the launcher to ensure the fueling.
Well,
of
the
main,
status of French Guiana
rocket
is a little bit
with liquid
complicated,
hydrogen
but
and, oxygen
because it is a
different
possession
temperature
of
going up to
France.
-250
But
degrees.
continentally,
And they're
it's
also
in
able to
South
maintain the
America,
constant
yeah.
pressure in the tanks and the stability of fluid inside the launcher up to the liftoff time.
And feeding the same cryogenic fuel into the bottom of the rocket. You can't see them at the moment, but if we change the shot, we might see the big tanks going in.
But technically, French Guiana is part
Yes,
of
we
the
do
European
the exact
Union.
same thing on the main stage, so the lower stage. We have the Mang fuel connection, but this time with massive system called Mang installed on the table, so 10-meter high and 100 tons.
Well, you've learned something
Getting
new.
close now to the
It is
1
UTC
mark.
-3.
À tous aux DDO, attention pour moins d'une minute. Top, à Giro, moins une minute.
Oh
We
yeah,
are 1 minute
Fran-
in, which
France
are very
does
best wishes
do
now to
Central
all the
European time.
teams. Good luck, everyone. Bon voyage. Ariane 6 and METOP SGA-1 with Sentinel-5.
well, I'll go inside, as it's quieter. Ooh, we're a bit hot. Not sure why we're a bit hot. But... Okay, I'll try and expand it. If it'll let me.
À tous aux
Transform.
DDO, attention pour décompte final.
Okay.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage de CFR et décollage.
Off it
La
goes.
propulsion est nominale. Pilotage calme, paramètres à bord sont normaux. Propulsion nominale. Les paramètres à bord sont normaux, la trajectoire est nominale.
Tracking. Well, I mean, this is not NASA spaceflight, clearly. Can't
La
even
propulsion
see the
nominale.
Vulcan engine.
paramètres à bord sont normaux, passage du transonique.
SGA-1 on board the third Ariane 6 rocket, blazing a trail across the night skies here over the Guyana Space Center, the European spaceport in French
No,
Guiana.
this
They
is
have
not
started their
military as
Pilotage
far as I
calme et
know.
passage de la pression dynamique max.
We are hearing that the pressure is calm, everything is going well, and we are looking here at 2 boosters, Vincent. They're doing
I
the
don't
work
believe
right
in
now, aren't
SRV
they?
Mach diamonds.
Yes, yes. we
Propulsion
can see the
nominale.
2 boosters, so we are in the booster phase. So the mass of the launcher on the pad, 535 tons. So to lift off, you need
Trajectoire
more
nominale,
thrust
écart
than
en
weight.
altitude
So
nul.
we need 900
Well,
tons of thrust, and the booster
talk
are
to them
providing
about it.
nearly 90%
Début
of
de
that.
poussée ESR, paramètres à bord normaux.
He's telling us that everything is going
Pilotage
well.
calme.
Everything is normal. Getting close now to... We should see, actually, those boosters being jettisoned.
Normal.
On our cameras, they will see.
I guess
2
they don't do
dots,
nominal.
kind of moving away from.
Europeans
We're
don't
looking
do
there,
nominal.
I think, at the, probably the engine on the main stage. There we go. We can see the boosters.
Séparation
coming away.
ESR.
And we have confirmation, and that's what it looks like. The 2 boosters falling away there.
La
Fantastic
propulsion
shots.
est nominale.
Yeah,
So lucky we've got incredibly clear
incredible
skies.
image, yes.
Looking now at the main engine, the Vulcan engine, which is now
Trajectoire
powering
nominale.
us. And he's telling us that everything's normal. Right now, the next thing to be jettisoned will be the fairing. That's the top, the nose
Manœuvre
cone
enroulée en
of the
cours,
rocket.
tout est nominal.
Everything's fine, and the fairing is protecting our satellites. Actually, we've got a good view of it there on our CGI images, the top of the rocket, the cargo bay, if you like. Our
Les paramètres à bord sont
satellite
normaux.
is stowed inside there, Vincent. It's got a number of jobs, hasn't it?
Pilotage calme.
Yeah, the fairing on top of the launcher has several jobs. So the first one, as you can imagine, is to protect the satellite on ground from dust, humidity, and so
Trajectoire
on.
nominale.
And
Too
at
dark,
launch, it is
or
an
whatever.
acoustic protection against a huge vibration generated by the different
I mean,
ignitions.
it'd be nice to see the booster set.
Yeah, and during the flight, so right now it protects the satellite.
Well, that's a nice
against
animation of the
and
payload
extreme
fairing
heat,
separation.
as we travel through the dense part of the atmosphere. And now,
We have separation of the fairing. It's
Yeah.
been jettisoned, so we don't need that anymore. We're out of the dense part of the atmosphere that you were describing. And
Their
look at that.
CG is better than usual.
We can see our satellite for the first time, and it's a big one. It's the gold structure.
yes, so
Fin
we
du basculement
can
roulé.
see the METOP SGA-1 spacecraft position on top of the launcher. So it is attached to the upper stage with a
Trajectoire
conical
nominale.
adapter. So METOP SGA-1, a big bird of more than 4 tons, positioned on top of the launcher in stowed configuration, of course, for the flight. So in gold color, we can see the multi-layer
Pilotage calme,
insulation
propulsion nominale.
that covers and protects the spacecraft sensitive elements from thermal radiation. And in gray and black, we can see other parts of the spacecraft like instrument or specific equipment.
Propulsion nominale.
Indeed, he's telling us everything's going well up there in space. And yeah, those instruments, we have 6
Yep.
different instruments on board. Let's tell you about them. If we go clockwise from the top
Pilotage calme,
right,
propulsion nominale.
everything's going well. Yazi, next generation, giving us profiles of temperature and humidity, also giving us information about the gases in the atmosphere.
Yes, and just below, the RO, that is to
La
say,
trajectoire est nominale et tous les paramètres à bord sont normaux.
Vulcan going
listens,
out.
to,
Yes.
how the signals from navigation
It's not
satellite
it going
like,
extinct like
GPS
it's a
get
dinosaur kind of
and
thing.
through the atmosphere to map temperature, humidity, and pressure.
And then below that,
Tous les
we've
paramètres à bord sont
got,
normaux.
we've got MWS, the microwave sounder. Now that's able to see
Oh.
through clouds. And
Yeah, we have a
give us
Vulcan
information
engine
about
and a
temperature
Vulcan
and
rocket.
humidity, as well as snow and ice.
Yes, and on the
Speaking of
other
the Vulcan
side,
rocket,
we have the 3MI.
They've started their stream.
which is,
Good evening,
that
and
is
welcome to the
a
live
new
coverage
way
of ULA's
monitoring,
Vulcan
the
USSF
tiny particles,
106
the
launch.
aerosol
But
high
we've
in the
got
atmosphere
plenty of time on that
associated
one.
with the formation of clouds, and just above
Pilotage calme, les paramètres à bord sont nominaux.
Sentinel-5 that will gather data about our atmosphere and air quality as part of Europe's Copernicus Earth
Ear
observation
bleed?
program.
Indeed, and
Trajectoire
then,
nominale.
right at the top
Huh.
on the top left-hand side is Med Image. It's a visual
Shouldn't have been loud,
and
though.
infrared imager, giving us high-resolution images, which are very useful
Propulsion nominale.
for. He's telling us that propulsion is normal, very useful for looking at the clouds and the land surface. It's also useful for looking at sea ice and the surface of the oceans. So 6 incredibly
Il reste
important
1 minute de poussée Vulcain.
instruments, all packed on board one satellite bristling with technology. And our satellite
I mean, the Apollo audio is even more complicated half the time.
European excellence.
Pilotage calme, propulsion nominale.
In observation from space, it was built by a consortium of different industries led by Airbus Defence and Space. Now, quick word about
Les paramètres à bord sont
trajectory.
normaux.
Top right-hand side of your screen, the green line is the planned trajectory, and the white cross is our actual.
Yeah, it keeps quite an angle.
So, we are burning Vincent, the main stage. It's that whopping great big tank of
Propulsion
fuel
nominale.
in the middle of the rocket.
Yes, we are at the end of the main stage flight. So the main stage, 33-meter high, a mass of
Les paramètres à bord sont
23
normaux.
tons, and fueled with 154 tons of cryogenic
Extinction
propellant.
Vulcain.
Yeah.
And he's just confirmed there that we've switched the main stage off.
Séparation LLPM.
And we have separated it and jettisoned it.
Premier allumage Vinci.
And we have ignition, our first
Tous
ignition.
les paramètres à bord
of
sont
the
normaux.
Vinci upper stage, and everything is going according to plan. So yes, now we've really gone into the next phase of our flight. The upper stage has taken the baton. Its job is
Orbite
to
atteinte à
deliver.
extinction Vulcain nominale. Les paramètres à bord sont normaux.
Everything's going fine. Everything's going according to plan. Its job is to deliver its
Pilotage
passenger
calme.
to its required destination in space, where we can drop it off. And to do that, it's got the
Drop it
engine
off.
on it, which is the Vinci.
Yes, the Vinci. So the upper stage is equipped with the Vinci engine. So
Les
we
paramètres à
need,
bord sont
two
normaux.
ignition of the engine will be necessary to reach the separation orbit. So and now we are in the first boost of this. The first boost of this upper stage.
Well,
engine
I don't
for a
know.
duration
I
of
mean,
700,
I guess this is the
Premier
plume
allumage
that they
absolu.
got.
Les paramètres à bord sont normaux.
15 seconds. That is to say, a little bit less than 12.
Yeah,
12 minutes.
probably we wouldn't be
It's just
able
announced that
even
we've
be
switched on
seeing a
thing called
plume,
the
so
APU, and
it's
new
true.
device.
Yes, the APU, an innovative new device on the Ariane 6 upper stage. So it performs a number of critical functions,
La propulsion est nominale.
including helping with engine reignition and enhance
Pilotage
finally,
calme, tous les
the
paramètres à bord sont normaux.
versatility of Ariane 6.
Our flight path takes us, as you said earlier in the show, Vincent takes us up over
Trajectoire
the
nominale.
North Pole, heading up towards the Caribbean, and we'll be going past Canada, up over the North Pole, and then we'll be coming back down the other side past Southeast Asia, and we will be separating our satellite over the New Norcia tracking station, which is in southwest Australia. The CVI teams there, the quick look telemetry teams, focusing hard there. Can see a Galileo, that was our tracking station.
Pilotage calme.
tracking us.
Paramètres à bord sont nominaux.
Here at
Hydrogen,
the Space
oxygen
Centre, we're now going
tubes.
into the range
Acquisition
of
Vinci is a
navigation
hydrolox.
the Bermuda tracking station, so we're checking in there and saying hello to the teams in Bermuda. Now,
Trajectoire nominale. Paramètres à bord normaux.
satellites do
And
all
yes,
kinds of
KSP
important jobs.
KSP plumes are all
That's why
alive.
we need rockets.
Why do we need rockets?
Changement de régime APU nominal.
I'm gonna tuck them back in the corner now.
We've all at some point looked up at the stars and dreamt of being someplace else. But outer space isn't someplace else anymore. It's here, it's now, and it's essential. But why go? Why do we need rockets? No rocket, no satellite. And without satellites, a whole world goes dark.
Pilotage calme. Propulsion nominale. Tous les paramètres à bord sont normaux.
Telecommunications, Earth observation. uses space today? Farming, climate monitoring, energy.
Trajectoire
security.
nominale.
Space makes life better. Here on Earth. Satellites guide tractors, forecast cyclones, monitor air quality, connect remote regions to the internet.
Pilotage
and
calme,
expand
propulsion nominale.
access to education, healthcare, and the economy. Satellites launched by Arianespace connect the world. Each mission brings our world into sharper focus and more within reach.
Tous les paramètres à bord sont normaux.
For any of this to work, we need a gateway to space, a precise trajectory. That's what Ariane 6
How boring
does.
space actually
It is
is.
built to adapt to every mission.
It's
from
pretty
low
boring,
Earth
alright.
To deep space, to single payload, dual payload, or rideshare flights. And it all begins
Pilotage
with
calme,
Ariane
propulsion
6,
nominale.
Europe's space
How do we
port.
make
That's
space
where
more
Ariane
exciting,
6
darn it?
takes flight. But launching a satellite isn't just pushing a button. It's a high-precision, high-complexity, tailored mission. That's where
Trajectoire
Arianespace
nominale.
comes in.
Paramètres à bord sont normaux.
Like the conductor of an orchestra, from contract to orbit insertion, Arianespace adapts to every mission for customers around the world. Governments, space agencies, private companies. And in a world where space has become a strategic domain, Ariane 6 embodies reliability, innovation, and independent access to space. Because satellites launched by Arianespace watch over our lands, our seas, our world. Space is no longer somewhere far away. It's what connects us here on Earth.
Fin de visibilité de la station de Galio.
Space is closer than ever before. He's just told us that we've gone out of the range of the tracking station at Galio, but we are now in Bermuda's range. So, yeah, it is
Trajectoire
it's
nominale.
closer
Tous les paramètres à bord sont normaux.
than ever before, but for this rocket ride, we have to go on a bit of a roller coaster. If you look at the top right-hand side of our screen, you can see the trajectory goes up and it's going to go down a bit.
Yes, we can see the evolution of the altitude versus time, and at the time being, we can observe a decrease of the altitude in order to optimize and maximize the velocity by taking advantage.
Focus
of
on
the
Vulcan
velocity.
now? But it's not made
propulsion
orbit yet.
nominale.
To maximize the energy and able to optimize the conditions at injection.
What if it smacks into the atmosphere?
We're dropping a little bit in altitude now.
Aren't they gonna have one of those
And
T-minus
higher
4
and
holds
higher
or something?
flight.
To attain the proper
Here on
flight
the
path,
hill,
while minimizing the
outside
dynamic
the
pressure
spaceport.
experienced.
They don't even
during
have the
flight.
clock up right now.
Trajectoire nominale.
Vulcan
Tous les
then reaches
paramètres à bord
Mach
sont
1.
normaux.
CDI, the quick look telemetry team, here they are. This is they're really concentrating hard at the moment, aren't they?
Yes, so the quick telemetry team, so located at the Montagne des Pères outside the.
Oh,
the spaceport.
well, it won't
So
get more
they're
funding for
collecting,
NASA, maybe
real-time
Space
data
Force or
on
whatever.
which, the launcher sends, so this includes the status
Le
of the
pilotage est
engine,
calme, la propulsion est nominale.
trajectory, and flight control, and they
Why would the
compare
space laser
live
get
data
anything for
from the
NASA?
rocket to what has been predicted, so this allows them to continuously analyze the launcher behavior and confirm that it is as expected. And of course, they can confirm at the end if the satellite is well separated as planned.
Trajectoire nominale. Les paramètres à bord sont normaux.
And the range operations manager is listening on his comms loop. So once they have confirmed the major events, then he calls them out to the rest of us across the range. Now we are 15 minutes into Metop SGA-1's journey to space, and lots of experts are going to be eagerly awaiting the data from it. One of those is the European Centre for Medium-Range Weather Forecasts.
Well,
Now, when
but
you,
we're interested in the
look at
actual
the
NASA,
weather
right?
result, it tells you that it's the third hottest July on record. They
Regardless
actually
of
rely
what
on
the
data
public
from
feels
Trajectoire
about it.
nominale. Tous les paramètres à bord sont
And the
normaux.
teams there gather information from
And
the
I don't think
satellites
the
and
actual
put them
NASA is going to get
into
anything out of
models.
that.
The Copernicus Atmosphere Monitoring Service are particularly looking forward to the data from Sentinel-5 to help them monitor the atmosphere and forecast air quality and climate change. And the director of the Copernicus Atmosphere Monitoring Service is with
Pilotage
me
calme,
now.
propulsion nominale.
Few
Dr.
minutes.
Laurence Rouille.
They still have the clock on there, but alright.
Thank you very, very
Alright,
much
alright.
for coming up to
Yeah,
the commentary box and swapping
fine.
seats with Vincent.
Mute you. Unmute you.
Start.
Alright, switching video. What?
140,
Okay.
Launch enable.
135,
FTS armed.
T-minus 90 seconds. The launch vehicle, ground systems, payload,
Here we go
and
again.
Eastern Range are go for launch. For those of you just tuning in, I'm Chris Beltry, joining
Well,
you
we
for
have
today's live
our
coverage of USSF
second newish
106
rocket.
atop ULA's Vulcan rocket. At this time, the team is not working any issues, and we're proceeding towards liftoff at 8:56 p.m.
I think
Eastern
this guy
Time.
is an AI creation. No. It's theory.
T-minus 1 minute.
Report range status. Range green.
That's what I'm saying.
45,
Vulcan takes at step 3.
34,
34.
30, EE4 start box, go. 28,
She just picks random
Verify
numbers.
ECS routes for launch.
20,
Status check. Go Vulcan. Go Centaur. Go SF-106.
Those were the weirdest voices for Go Vulcan and Go Centaur, too.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 1. And liftoff of United Launch
You had me
Alliance
going for a
Vulcan
sec
rocket
there,
carrying
person
USSF
announcing it.
106 for the United States Space Force.
I'm going like, those
Continuing
voices
ULA's
are
soaring
literally
legacy,
worse
National
than
Security
the
Space
voices
Launch
I had used
the
on my
innovative
launch that
Vulcan
were...
rocket.
that Pekka criticized.
Half mile an hour.
So, I feel vindicated somehow.
Completed our pitch and yaw program. Body rates turned to 0. P's gone to closed loop control. And we've completed our roll program. 3 miles in altitude, half mile downrange.
I think mine's were realistic than Pekka.
And Mach 1, Vulcan supersonic.
I think the uncanny valley is here.
Vehicle's traveling at 1,500 miles per hour, right down the center of the range track. Max Q, maximum dynamic pressure.
Well, that's
Engine
all
parameters
sorts
continue to
of
look good.
plumage.
Hydraulics good. Five miles downrange.
You are hearing Daniel Brunson providing launch vehicle ascent data.
Good indication of SRB burnout. Preparing for SRB jettison. B4s continue to burn nominally.
Well, with respect, let me
Good
turn off
indication
the
of SRB separation.
captioning.
B4 is entering its first throttle bucket. And
Yeah,
guidance enabled.
I felt like the
Close steer.
captioning was not sufficiently
point,
We
good.
just heard
Vulcan's now half.
confirmation of solid rocket booster jettison. These foreboders augmented the thrust of the main vehicle engines at liftoff, giving the Vulcan rocket an extra boost on its journey to geosynchronous orbit.
27 miles downrange. Continues right down the center of the range track. Traveling at 3,200 miles per hour. Engine continues to burn nominally. Body rate's looking good.
Well, we got 2 launches. Rare to catch 2 launches in the same hour,
And we've got activation of the RCS pyro valves on the upper stage.
without one of them getting scrubbed, of course.
34 miles in altitude. Approaching 4,000 miles per hour.
Miles per hour.
Body weight
Gosh,
continue to look as
ULA.
expected. Passing 80 miles downrange, Vulcan continues right down the center of the range track.
Yes, but they're also sort of hyper-American. Like they want American space lasers desperately.
Passing through 45 miles in altitude.
Sorry,
107 miles
Bruno's
downrange.
been going on about Golden Dome and everything.
Engine parameters continue to look healthy.
Go away, little thing. Oh, now that you noticed that it was metric, they've hidden it. Oh, there's back. Whoa. My plane just had a bit of
We're
a
now a
jostle.
quarter of our original liftoff weight. 169 miles downrange, 56 miles in altitude.
Quarter of our liftoff weight. Wow.
Good activation of the upper stage PU motors. Vehicle's traveling 8,400 miles per hour.
This is Vulcan Mission Control at T plus 4 minutes and 30 seconds. We're about 30 seconds away from our next mission events, booster engine cutoff and booster separation, followed by start of the main engine and jettison of payload fairing. Let's return to Daniel Brunson.
And we've completed boost phase chill down.
Drop on Elsie.
And good indication of shutdown.
Booster as in
Good
the core.
indication of center
Yeah.
separation.
The core can be called booster as well. It's
Got
weird.
pre-start
but
on H2 and O2.
Traditional. Well, they actually have a second stage cam, even though it's a
And
Space
good start
Force
on the
thing.
upper stage engines.
But that's
Two
probably
good
all
all
they're
times.
gonna show us.
Good indication of PLF jettison. Centaur PU set to open loop control. Body weight's looking good.
Too
This
complicated.
is Vulcan Mission Control at T plus 5 minutes and 45
He blinked.
seconds. We just heard flight commentator Daniel Brunson confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. As the mission continues, let's take a look at the important work done by the Space Force's Space Systems Command.
Ariane is in orbit. I don't care what they're going on about. But they're probably not gonna even tell us when it gets to orbit or something. Okay, I'm not sure I want the ad for the Space Force, so... I don't know, maybe AI has gotten good enough to do blinks. Get that right. Okay, well, we're back to the flight. I guess we'll do Apollo 13 now then. We're gonna pick it up with the CO2 issue. Pretty under. What were you looking for exactly?
Just tell him that we're standing by for his maneuver to PPC
Onboard camera, so... well...
He may be gone minutes.
Okay,
Sure,
good
yeah,
evening. Becca, have a good sleep. Thanks for joining us. Starship Flight 10. Well, it depends on what time it is.
Very little in flight, but it's hard to get that good. Okay.
No, they've done it at odd times too, so I don't know.
Go ahead, flight. Roger. Bill, how long before you think
Let me
you're
see
gonna have a good
if
idea how well that burn
the schedule has anything about the relative time. I don't think so.
First up, what you're saying is about an hour and a half. Right before we go off the okay, good.
Oh, it looks like it's gonna be 4:30 p.m. on the 22nd. Well, Friday is a good day if they actually go on the 22nd or 23rd or 24th, then it's highly likely. See, if they go in the morning and it's right at dawn for them, that can be too early for me because I'm 2 hours behind them. Which mountains? Well, I don't know which bit of snow you were reacting
Okay,
to.
just some info. We're working up a procedure for you to use command module LIOH
Pekka
canisters.
is a viewer who is also a KSV modder.
In the LEM, so that as time passes in the mission, you can continue scrubbing the LEM atmosphere. And this whole thing requires
I do not know why Pekka
a
chose
kit
the name
so
Pekka,
that you can
but
attach the hose, or modifying the LIOH canister so you can attach the hose to it. So
Clash
sometime in the
Royale
future we'll be
Tower.
coming up to
Okay,
you with that
don't know what
procedure.
that means exactly, but
Second point is we're
I
standing by to
don't.
watch your
I'm not gonna assume. There's probably
the,
other
ETC
things.
procedure.
I remember seeing something else that was called Pekka too. So let me try and figure out what that was. I don't even know if that was what he was calling himself after.
And Vance, I assume it had also been thought up that we got 2 extra secondary cartridges.
Pekka is a Finnish male name derived from the Greek name Peter, which means rock or stone. So there's that. But that doesn't have the dots.
Yeah, we wish we could send you a kit. It'd be kind of like putting a model airplane together or something.
So we've got the Clash of Clans and Clash Royale one.
Get it all put together.
What are we thinking out of, man?
One canister with a plastic roof.
I thought there was something else, but I can't find it right now.
Just for information,
Maybe it was just this Clash of Clans thing, or Clash Royale.
including some one large piece sounded like a rapping off of a line of some sort that still was with us.
Roger, copy, Jim.
Even after our free return mid-course yesterday.
So we're 10 minutes away from Juneau. I might as well go a little bit further, so a bit of a change of plan. Vulcan launched and got to the second stage. I don't know whether it was successful or not because they don't tell us. Well, they didn't show us what was happening after the second stage, but they'll probably tell us at some point. But they're not gonna show me. And I'll just wait until the word on Twitter, I assume, will be told.
I don't see any way around it, Chief. He sure doesn't seem to be doing much, does he? Down.
I will monitor Twitter to find out.
I don't know. What if they try that in the simulator? I can't seem to get roll to go up. What's going on on these?
Control for flight.
Flight.
Yeah, I know. I've been monitoring that conversation yet.
Dozen bytes. Well,
He's trying to get the roll out. He's going in the wrong direction. Yeah, but he said he's tried it both ways.
I thought he was a freedom of speech person.
Branched off of the evaporator, sublimator, to overpower the minute.
Twitter's nicer than what a lot of people call it. Well, I mean, the problem with X is we still don't have a really good term for what we call tweets, right? At least no term that would be specific to what was called Twitter, so... X's? No, I don't think so. So, no... I mean, it's sort of like the artist formerly known as Prince. We still call him Prince. It's not really an oversight. Elon is very obsessed with X. X.com, SpaceX, Model X, and X, and then he called his kid X too. Except, I guess Grimes didn't let him and added all the other letters. But he would definitely have called his kid X. Well, I don't think he wanted to commemorate his exes. It is unclear to me why he's stuck on X. Honestly, setting up a PTC the way they are is a nightmare because the RCS on the lunar module isn't really well balanced for having both the lunar module and the command and service module. It's a little bit wobbly like that. Having a nice roll isn't exactly easy.
You really think that P-52 is going to take that much gas?
Yeah, but they had constant problems with the
Jim, we don't have any data
PTC being set up.
your movements right now. How does it look like this procedure is going to work out so far as getting an attitude
For Apollo
set up,
13.
the first part of the procedure?
Let's use the PPCA flight. Put it over there.
I've been trying to use a bit of impulse only attitude control.
That's what they're complaining about right now. So.
But with the attitude control only in this configuration, I can't command the roll the way I want to. So I had to go to the TTCA to get my roll to build up towards zero. It was going decreasing towards 270. I really don't know what the combination is with the attitude control if you can get the control to pitch your roll the way you want to.
You really like to do flight, just take the roll out first.
You've got to use the TTCA.
Roger, copy.
Use the PPCA flight. Try to take the roll out first. Like you want to remove the roll with the PPCA.
Pitch and roll going towards your designated amount.
I was trying to look over there where
And I'm going up past 321 degrees and roll. And I'm letting them go that
we're in the vicinity of Juno.
90 and pitch and 0 and roll. I will go
I think Juno's just right ahead there.
the rate.
Concur that? Sounds good. Okay.
There's the runway. That's Juno International, if you can see that runway there. Would be a convenient place to land, but right now we're going at 371 knots, which is a nice clip, and it's a 65 knot wind that will help us out, so I think I'll stay flying and head south further.
Flight control, double control. One hint here you might get in is that if you get the noise from pitching you off for the time being and just concentrate on roll, these roll to zero. Forgetting about pitching yaw. Should help you control that. Okay. What you're saying is ignore pitching yaw and concentrate on roll, right? Right. That's when it's crossed up with the bag, the word, okay?
We've got to rig up
Copy that,
the
Captain.
method of using those lithium hydroxide canisters.
That's what they're suggesting to get this thing set up due to the fact that we've got the majority of our cross-coupling in roll to ignore
Not exactly right there, but
and then go back to preference, then you're going to take the off, whatever you get when you establish your attitude. So really, don't worry about you.
We just got a mantle on and
Get roll where we want it.
light. I take it
Establish your pitch attitude.
next most important home improvement project is the screened-in porch. Oh, to protect against mosquitoes, yeah. Okay, good evening to you too, satellite. Have a good rest.
Tell me about the PCO2, telling you.
CO2 value was getting high. We had a tip DCS light and a blinking component light.
Okay, copy.
Okay, I'm copy that flight.
So, CO2 problems.
Okay, let me ask you a question. Can anybody predict what the CO2 level, CO2 is going to be at the end of the sleep period here?
How bad is the CO2 gonna be while they're sleeping, is what he's asking.
Well, we can try to run it out, but that's going to be what? That's what I'd like to know.
Stand by on that PPCO.
And the answer is it's gotta be excessively high.
Okay, but we couldn't work with, well, my question is going to be this, couldn't we switch over to secondary and then come back to your primary at the end of the sleep period? Because I'm just really wondering if these guys have been working pretty hard, probably too good to not have guys moving around cockpit switching.
Because they're going to
Okay, read your log there now, Joe.
For them to go through the entire sleep period, they're going to have a first
Okay, did you hear what I just said about the ECS light and the blinking
that one won't carry on that
component
call.
light?
Okay, we got that, and stand by.
Well, let me change my destination if I can here.
Okay.
Surgeon, go stand by.
Not much.
Surgeon from flight. Capcom, tell him we'll be back on that particular one. We're still going to follow the
Jack, we might have to have you rig up the CO2 tank they're talking about.
Okay, but now it's gone to Juno.
Calling flight second.
Getting a long ways to go. Go ahead.
Okay, Jim, we're going to have to get back with you in a couple of minutes on whether or not we switch over at this time to your other canister.
Flight. What I'd like to do, I'd like to
point,
switch into our secondary canister
it might
for the
help
sleep period here.
in setting up this PTC if you
Take us through
concentrate
the
on
sleep period,
roll
and
first
that'll give you some time to think
and
if,
get that
what level
going,
you want to go to in the secondary.
and
we want to switch back to
then
the primary.
work
Go
on
ahead.
pitch when roll is established and sort of take
Band,
whatever
did you
yaw you
monitor that?
get.
Oh, I didn't, Jim, I'm sorry. Okay, Bill. What I'd like to do is get these guys through the sleep period. CO2 is running about 7.8 now. They're estimating we'll probably get about another 4 hours before we'd have to switch canisters. What I suggest we do is, as we go into sleep period, we'll switch to secondary.
Oops.
And then make our decision tomorrow as to whether we want to stay in secondary and to what level, or if we want to switch to primary and go back up to 15 millimeters. Secondary's going to get the only suggestion is secondary's good for 6 hours at a
No, not from.
sleeping
Shoot.
metabolic rate.
Once they get rolled down, I don't think it'll be too bad.
Okay, I'll tell you what. I'm telling you, will you and Surgeon and Span get together? That's right. Calling flight signal.
I want that one. No?
You've got one crewman that's awake on watch, right? That's kind of it. I'll tell you what, let me solve the PTC problem, and you guys figure out what you want to do in CO2. Go ahead, Dick. Okay, let's get the yaw out of it. Try to send it to me. Let's go ahead and make yaw 0.
Okay, from that is fine. And then to Prince Rupert. Okay. That's fine. That should work.
How much gas will you use? We haven't hardly used anything right now, only 1% so far. Okay, now you're suggesting what now?
Well, somebody's laughing. Fred Hayes is laughing for some reason.
That would be the quickest way to do it. If you decided you can't seem to do it, you just yaw to 0. Now you just got push and roll. Okay. So have him go ahead and just yaw the thing around, so just yaw to 0. Then you can take push and roll as you desire.
So 40 more minutes to Prince Rupert is where I'm gonna end up.
Close to 0 right now. Nope. Is it 299? No, I can have to do a 60-degree yaw.
Prince Rupert is in Canada, British Columbia. So basically we'll have completed the Alaska portion. Alaska's so huge.
Corey Houston.
And then pitch, what is it, 90?
Okay, Jim, since the first recommendation on how to maneuver PTC didn't work out, we have another one. And you might try this. Put yaw at 0, then start on the roll, and the pitch after that.
Do you read?
Yeah, I do now. Go ahead.
Okay, you might just tell me what sort of material you had in mind to build this mailbox out of, and Jack and I will go to work on trying to construct this thing. I assume we'll use the space-age mailing wire or the gray tape.
That's a firm. We have a lengthy procedure here, but in short, you use plastic as a covering for the whole thing. You put some kind of a stiffener at the top so the plastic doesn't suck against the LIOH entrance side. You need grade tape to stick the whole thing together, and you need something like a sock to put in the bottom so that the outlet side is plugged up. As it turns out, the flow is rather U-shaped through the cartridge, Fred. If you plug up the bottom, it comes in one side of the top and goes out the other.
Okay. Hold on a minute. Let us go get a cartridge and within the hand I'll speak to you more.
Okay, just to roll up there now, folks. We'll just put it in. That'll be all right. Let me tell you this. If this does not work, our procedure is going to be as follows. RAS, the Z-axis, general direction.
Really, I think we should give you a more detailed procedure on that. In general, those are the materials that are to be used, but let us get back with a detailed procedure on how to make this cartridge arrangement work.
Okay.
Like, we told you this was a long procedure. It took a while.
And to answer your question about PTC, man, it's really difficult to get yours to right away. So what I'm doing, we're working towards zero right now.
Just check down, let's try forward on it.
Roll is working towards zero. So it's just going to take some time to get there, that's all.
Roger, there's quite a bit of noise now. I understand you're still having a problem getting there with the PTC.
It's looking better now.
We are getting there, it's rolling.
Right, okay.
Let me know that we get on this one. Which one do you want forward? That's down. Let's try forward on here.
Aquarius Houston, let's try forward Omni.
Sliding, so we didn't hear that last call. Still want to try forward on it, right? Excellent. That's it. Control, how you looking? You look good, Mike. Okay. Any flight? Go ahead, Circle. You want to entertain our proposal?
Okay, Houston, how do you read now?
Lithium hydroxide chemist. Right. Span for flight, you monitoring this. Go ahead, flight. Okay, I just want to make sure that the people back there who worked out the lithium hydroxide plant are monitoring now what we're discussing with safety. Go ahead, sir.
Clear now. Go ahead.
Okay, Dean, the way we see it is there's...
Okay, I switched to forward Omni now.
There's no problem.
Roger, that's better.
Okay.
Go ahead, sir. The way we see it, tell me agrees with this, that there's no problem with running the primary lithium hydroxide can to 15 millimeters CO2 pressure. Okay. We will have one crewman that will be on comm watch anyway, and when it gets to this level, a simple word to him to switch cans, to switch to the secondary, which can be done without any interference with the other crewmen. Okay. It's a simple hand. What's the build-up rate? What rate do you expect when you approach the 15 millimeter level? I expect that from this point until we hit about 15 millimeters, it's going to be about 3 hours. Okay, but at the time you get to 15 millimeters, what's the rise rate? I.e., what I'm leading toward? It starts high, then fast. What I'm after is we may not be communicating with this guy throughout the entire period. He's going to be in a PTC. It's probably going to be difficult for the crew to be switching on me, so we may not be able to get him at the right time you want to talk to him.
So, yeah, the problem they have is they've got one guy who's going to be switching the canister on the spacecraft, but the spacecraft is going to be rolling for passive thermal control, which means that the antenna isn't always going to be pointed at Earth. And then they're not going to have him constantly switch the antenna, so they're not going to be in constant communication with him, is what they're discussing.
What's going to be the effect of bringing the biomed data up? We lose about 2-3 dB on our downlink signal strength margin. Okay, is that going to make any significant difference to us? Yeah, we'll lose.
Well, the ULA account has not said whether orbit was achieved yet, but they're going to geosynchronous, so it's probably going to be a while. I can barely hear the spacecraft audio though.
How much longer do you think it's going to be before we get an attitude here? I'd say 15. Okay, and then we've got another about 15 to 20 minutes to damp race and another 15 minutes after that. So we're talking about some part of about an hour before we're still setting up the PTC. That's what it looks like.
Hang on there.
Right, sir. Span. They all consider one of the primary to 15 millimeters and then narrow the thing. Okay, I'm going to talk to Jim McDivitt out here. Go ahead, tell me.
Yeah, we'll give you try to give you about a 30-minute warning on the approach to 15 millimeters.
Okay.
I think that's good. Any flip-flops you got on that monitor.
Okay.
Apollo Control Houston, 80 hours, 49 minutes now to the flight. We show Apollo 13 at 9,118 nautical miles away from the moon and traveling at a speed of 4,718 feet per second.
He's almost there, Flight. He's almost there. 10 degrees in roll and about 18 degrees in yaw. Okay, well, which recommendation gets here first?
Revised flight plan shows a rest period of 6 hours for both spacecraft commander Jim Lovell and Jack Schweigert, command module pilot, starting at 81 hours 30 minutes.
And go for flight. Have you and the surgeon been able to come to some conclusion on biomet data?
Roll to zero. Just roll to zero. I'm going to put it at home. Then I'm going to take out yaw. Leave it pitch the way it is. I'm going to pitch down.
Sounds good. Okay.
Of course, the start of the sleep period is dependent on setting up attitude
how much
for
further below this
PTC.
level are you going to be able to get when we
We're at
power
80
down?
hours
What, 8
and 51 minutes now to the flight, and this is Apollo Control Houston.
Okay.
When we have to start chasing that cannon. 15 even. Huh? Let's get 15. What is it right now? Nothing. No. We're not reading anything. Well, that's the one they wanted you to leave in. It's in. That's how it triggers the... Okay, Jack, I gotta push in on this thing to stop it.
You monitoring air control? That's the sound is fine. Okay, is he stable in attitude then? Now he's out of six now. He's back down to 6 a little bit.
Yeah.
He's slowing it down now for the roll. Right there at the roll now. Hold out. Hold it. Good. Good.
I just turned the alarm back on. Now that it's on steady, I'll leave it on. I can understand why I get a power. Oh, I know. That's why.
We are going to be landing at Prince Rupert in British Columbia. I was trying to get to Seattle, but I think it's better to just land at Prince Rupert for this flight. So actually, so I'll be concluding soon. We are about 25 minutes away from Prince Rupert. We'll start descending in, oh, maybe about 8 minutes.
You got pitch and roll squared away now. Oh, he's coming down and roll. He's getting out like that roll because that's how far are we away at this? Going, so forgetting about that, I'm willing to try it. And if we lose too much low bit rate data, according to telling you the controls requirements, we can always go back on board to the no bow net configuration. Okay, is this going to interfere with our voice? No. Okay, looks like we can always back out of that one. I think it's looking right at go control. You set the roll now. Is he going away from it now? It appears that way. That time we showed him with the roll nose, but he seems to be moving out. Okay. That's a surprise, you know. Sure he sees it. All right. Could I hold off on that so we see if we get something to stand here? However you do it, you're going to have to orient your pitch. Pilot pitch, this is your x-axis, I assume. Normal to the sun, so that's the only one we need to use the span recommendation. Otherwise, you got to have your x-axis normal to the sun. Looks like it's faulting the wrong direction. Okay.
Aquarius, Houston, over. Jim, it looks pretty good, except that the pitch is going out in the wrong direction now. Over.
I concur. What I'm trying to do is get roll to zero, and I'm trying to bring yaw into zero. And as soon as I get those two pretty well matched up, then I'm going to take the pitch and try to pitch it down.
Okay. Okie doke.
Apollo Control Houston, 80 hours, 56 minutes. Apollo 13, now 9,420 nautical miles out from the moon. Velocity reading 4,701 feet per second. Our real-time flight plan has just updated the start of the rest period for Commander Jim Lovell and Jack Schweigert. That time now reading 82 hours ground elapsed time. Jim Lovell still working with establishing the proper attitudes for passive thermal control. Apparently roll is pretty well nulled out. Still moving out of it.
I'm going to assume that the crew stays at this power level for the next 30 minutes to get this peak.
We're at 80 hours, 57 minutes in the flight, and this is Apollo Control Houston.
Assumptions, tell me how much power I've used, what I've got remaining, what average we have to maintain throughout the rest of the flight plan, and give me a summary for the same assumptions on water, and write down something in lithium hydroxide for the crew update, and I'd like that in about 30 minutes. Okay.
Okay, now I've got pitch going down. I've got roll almost zero and yaw is almost zero.
Okay, copy there, Jim.
Telling you flight. Excuse me, sorry, ankle from flight. Fighting thing. Right, I got a procedure I asked FAO to work out for me a while on the switching to the crew. We'll see if they can give us some data periodically here throughout the night. We might take a look and see if we think that one's a good one. Copy that. Control, how's he going? He's coming in flight. Coming down his pitch.
All right, time to begin descent. Whoa, lots of turbulence. No, not what I wanted to do actually. That would be right. Nothing in particular about the result of the Vulcan launch yet. And Apollo 13's up.
Oh, how you doing?
They were being quiet.
Slow. Okay, how far away?
Slow.
Houston, what's an acceptable pitch attitude that you'll take?
I believe what they're going to say is you got to hit your 90-degree pitch attitude. Stand by one. Capcom, tell them we're working on that right now, and it looks like 90-degree pitch is the one we got to hit.
Houston.
So we've got a rate of about 2 degrees per minute pitch right now. Maybe about 5 minutes to do it. Okay. And as behold, there's roll. Roll, but not a yaw. Okay, but the yaw you're going to take what you get against.
Roger, what's an acceptable pitch attitude that we can have for PTC? I can go to auto anytime now. I'm looking at 118 degrees of pitch. Basically 0 roll and about 14 degrees of yaw.
90 degrees pitch.
Why, he's never going to get there. He's been making out for this thing for an hour now.
18 degrees
Who's
of pitch.
talking? Capcom. Why don't we let him do a Bird 49 twist?
Stand by.
You want to make your auto maneuver control? What that's going to do to us about this flight is put us in a high rate. Once we get there, we're not going to be there at a high rate. It's going to take us a while. Next thing we have to wait for the instructions because the rates are down. There's less than a degree, or maybe wait some time.
Stand by a minute, Jim. The pitch is the important thing, but stand by one.
Okay, it's coming down.
You got it. Fine, you get it in there. Because you're going to pay more time-wise while you wait for your rates to stabilize out.
Yeah, we've gone a hell of a long time without any sleep. I see we've gone a hell of a long time without any sleep. We're going to have to start thinking about getting people back to sleep again because I know.
How far are we out in pitch control?
I didn't get any sleep last night at all.
Okay, pardon? 24 degrees. Okay, so he's only about 24 degrees away from the altitude we want. Still moving in the right direction, control? Okay. Your low count, what is it, like 22 degrees now? 24 now. Channel 1 point. Got it. Control the flight. Good. What's the orientation of the x-axis now? In fact,
Well,
y-axis
the
is
natural
flight.
direction for Prince Rupert is actually the one we're flying
Go
in,
ahead,
so we
Mike.
can fly
What's the
straight in.
orientation of the x-axis for the sun now? We don't have any data from it. Let me see what... Yeah, your roll picture, we don't know how to see it, you know what your estimate is. FAO, can you give me that data? Oh, you mean where the x-axis is of the statement number? I can tell you that. No, I'm talking, okay, translate that to the spacecraft x-axis. It's -2.
This is still Alaska. Basically, as soon as we get into Canada, I'm landing. Prince Rupert is right on the border.
You want to go at home here? I think it's all in place, like, yeah. Right, yeah. Okay. No, I didn't have it. Oh. Okay, so the X body should be normally the sun. This is fit. No, he isn't. Oh, I thought he was. No, he's fit 112. Flight is still picking. He's got the 110 now, flight very slow. control from flight. Good.
Corey,
We're ready to start stabilizing in this attitude. What do you want to do? Go to and hold?
Okay, Jim, would you stabilize your rates here at the attitude you're at now and go and hold? Over.
No, he's got a procedure there. We've got 5. We'll just go to auto flight.
Okay, will do. I'm now at 106 degrees, 106 degrees pitch, and 2.5 control.
Roger.
Okay, you'll monitor the rate of flight and get to 110, we'll let you know. Roger. Let me know when he's got it. Go ahead and go. 65 mile net, we need to go mile net right. Okay, stand by.
Yeah, I got your Cleveland. Life in the trash bag.
Okay, everybody, let's see if we can get settled down here now. We got a couple items that we got to talk to the crew about. I think we ought to talk to them about how we're going to handle the communications during the sleep period here, during the rest period. We got to talk to them about lithium hydroxide canisters. We got to give them a briefing on the consumables. Okay, and we got to monitor the data for adequate stamping to initiate the PTC.
Okay, Houston, you monitored my angles. It appears that it might be less than 1 degree per second.
Okay, we'll check them.
Stand by, we'll check them, Jim.
Tell them we'll advise them when the rates get below a 10th of a degree per second. Tell them they can start into a heat period or whatever it is. And we'll just monitor it and let him know when he's ready. Control from flight. Good, man. Can you give me what are his rates now? They look real low right now. Probably going to get a hack at it. Okay. We've only got the nearest 10 and the peak count is about 14. Okay. Okay, so when you get to a 10th, you'll let him go. Okay, he's low, but not low enough. Right, we'll keep watching it for a while. Why don't you suggest if he feels like it, start into his heat period? Because it'll take, what do you estimate, about 10 minutes here, Control? It looks like we're probably ready to do the second one here. It's like a few minutes. Okay.
Corey, Houston.
Go ahead, Houston.
Jim, that's firm. We're monitoring, and you're almost there, but we'd like to let him stabilize a little bit longer. Over.
Okay, we'll just hold.
And if you can now go into your eat period or do something else while the rates are stabilizing, why we recommend you relax over and get some chow.
Right, we'll do that.
In theory, there's a lighthouse around there. But we're probably, if there's actually a model, we're probably too high to see it anyway. Maybe there? Well, there's some sort of settlement on that island.
It's open, flight. Flight open flight. Go ahead, Mike. Did you review the procedure FAO gave me for Omni switching? Oh, that's affirmative. Mail has one there that includes most of that. Okay. Did I concur with? Flight control. Go ahead, control. Let's go on to step 8. First 25 down 7 is able to pump next step. Okay. Now you want step 8, 9, and 10. What do you want? How do that? All the way through to 11. 8 to 11. Okay. Countdown flight. Go. We're cleared to go ahead. We're going to have to figure out how we tell this to the crew to make sure we don't blow it here. We want to complete steps 8, 9, and 10. Okay, in the PTC. Okay, and then we'll monitor the rates again, and then tell them when to go into step 12, 13, and 14. Okay, so you think rates are low enough? That's affirmative. Okay.
Aquarius, Houston, over.
Okay.
Go ahead.
Okay, Jim, it looks like your rates are damped sufficient. Recommend that you go ahead with the Verb 25 now 07.
Well, we'll cross the United States.
On down through.
I'll go to Seattle, probably go down to San Francisco, and then cross the United States.
Look at it again before you go beyond that. Over.
I haven't got probably to Denver, something like that. We'll see.
Verb 25907 down through Verb 34 enter, and I'll stand by.
Righto.
What's your granularity, control? 4/10 of a...
Apollo Control, Houston, 81 hours, 19 minutes now into the flight.
Okay, why don't we do...
We presently show Apollo 13 at 10,431 nautical miles out from the moon.
Yeah, that's just what I'm saying.
Its velocity reading 4,600 to 49 feet per second.
We'll look at them, let them go through their eating.
A couple of points of clarification. The master alarm on the CO2 canister was expected to occur at some point in the mission. It is normally set at 7.6 millimeters of CO2. This number chosen as an alert to watch the canisters.
Yes, watch the canisters, the LIOH canisters.
The medical officials had agreed. Medical officials had agreed that
Mars Telecommunications Orbiter. Oh, okay. Interesting.
To 15 millimeters in order to preserve the lifetime on the canisters.
Okay, we have our ILS.
Here at MSC, the level in laboratory testing
band.
has
1620.
He says he's going to monitor the rates to 1620.
That's the way it should be done, and we're standing by for the rates
here
to stand
in
by.
the MSC laboratories. The levels
Okay.
using test subjects have been as high as 22 millimeters of CO2 with no ill effects.
Up.
On
The
our
canard's
passive,
moving forward.
Thermal control, and we have damped the rates at this point. There has been an effort on the part of the crew on the ground to perform this activity with minimum use of RCS propellants. We're at 81 hours at 21 minutes.
Maybe sort of think about rations, so I mean, just to make sure that we got enough to last us and that we get enough water out. I hate to run out of water on the last day. Take a look and see how much we got and fill them up and just hold them there. Yeah, and the stuff that's good to eat now will be the candies, the sandwich spreads, maybe the dehydrated stuff that you have to rehydrate is going to be kind of difficult. No, wet packs are good.
Oh, I see the runway there.
Matter of fact, we might use this as well. How about the push? Yeah, I know, but I mean the pushes are bombs too. We're damping rates. Well, maybe we ought to use the OPS first.
I'm a little bit worried about the trees and all.
Telling me you can flight. Can I go over your consumable status with you now?
It's a nice area, yep.
I want specific numbers and get ready. Guys, you gotta start Capcom down there, man. You might copy this down while one of the other guys, in other words, so you can translate it and read it up to the crew shortly. Okay,
Interesting on the winds sometimes, though.
copy that. Okay. Go ahead, tell it in.
Okay, we've got 1498 anchor out right now. Up at 81.4. We're running about 25 anchor out.
Okay.
I bet I have to turn around here, don't I?
As I said.
Target down there.
Okay. Take in the info.
1498.
And what are you getting down?
Gonna go down to
Well, I probably don't have to wait till the end of the runway.
That's not wrong.
Okay.
Okay, tell that. Say you expect to be able to maintain 61 flight hours remaining into 1498 and check flight roll average. And give me what's the average? What are the average? Let me finish this up. Give me an average request maintain. Okay, 24 and a half. Okay.
Guys moving around?
Well, I guess over here is okay.
Okay.
Okay, person walking around. Don't know exactly what orientation I should park in, but... Hello?
Apollo Control Houston, 81 hours, 27 minutes now to the
Okay, so we are here at Prince Rupert in Canada,
Apollo 13 now
northern British Columbia, and we'll be heading further south back into the United States, and then we'll cross the United States to Cape Canaveral. Maybe I'll go straight after we hit Seattle. I don't go over Montana much, and Yellowstone National Park could do that. I'll think about it.
It is normally set
So, well, I'm gonna pause
for a level
them.
of 7 point,
They're talking about the CO2 a lot. Yeah, CO2 concerns are right there. Yeah, they do walk right through the props. Anyway, so... something weird happened there. Alright, with that, thank you for watching, and I'll see you folks next time.